What's going on, 8th grade? How are we doing this week? We officially got the word last week that Governor Mike DeWine said that we're not going to have any more physical school, which I know is probably upsetting to some, happy for others, okay? And maybe some of you just feel in between, okay? Just know all those feelings are perfectly valid. They're perfectly fine, okay? But in this meantime, we're still going to have our online school. So you still have all your teachers and you still have all your friends here, just one click away, okay? So this week, in our week 4 of working on our online stuff. And by the way, y'all are still killing it out here doing all your work. Thank you. Appreciate that. Okay. This 4th week, we are going to be working on the Pythagorean Theorem. Okay. It's going to be something that's massively important, but yet not very difficult to work with. Okay. I think that you all will sort of like it. So, without further ado, let's get to the Pythagorean Theorem.
Today we're going to be talking about the Pythagorean Theorem. Now we're going to be going to the background just a little bit because it's actually kind of interesting. So, the Pythagorean Theorem is most commonly associated with the Greek mathematician Pythagoras, the guy who's on our left here. But there's a bit of controversy when it comes to this because there's actually some evidence that states that the Pythagorean Theorem has been documented as early as 1900 to 1600 BC by the Babylonians. So I'm going to leave this one up to you. What do you think? Do you think Pythagoras was the one who discovered it and made it popular? Or do you think the Babylonians made it popular? Now keep in mind the Babylonians were way before the Greeks, so let that be up to you. But let's actually get into what the Pythagorean theorem is. So, the Pythagorean theorem, or most commonly known as a squared plus b squared equals c squared, only works with right triangles. Okay? What makes a triangle a right triangle is the fact that it has one 90-degree angle inside of it. And I'm going to say that one more time. A triangle is a right triangle if it has one 90-degree angle inside of it. Something else that's kind of cool about this is that when you think about a squared plus b squared equals c squared, you can actually represent it like this, where it's a square, b as a square, and side length c as a square. And if you look at the areas or add these areas of a and b together, their sum is actually the same area as square c. So kind of cool. Some other things to note is that side C is the longest side of the triangle, and it's also important to note that the longest side of the triangle is called the hypotenuse. Okay, so a hypotenuse is always going to be C, and then A and B are two other sides of the triangle. So let's put a little diagram together here. So we know that the hypotenuse is always going to be the longest side, and we know it's always going to be C. And if you're having a little bit issue of like, how do I know it's the longest side? I can tell you that it's always going to be directly across from the 90-degree angle. Okay, directly on the opposite side. So that makes these other two parts legs. Okay, these other two sides of the triangle are called legs. Nothing special. And we're going to make this leg A and this be leg B. Now, this could be A and this could be B. It really doesn't matter. The only thing that does matter is that the hypotenuse has to be leg C or side C. Okay, so let's try an example of this. So I have the triangle with side lengths of 5, 12, and C. So I know I'm solving for the longest side, or I'm solving for the hypotenuse. So I need to input this other information into the Pythagorean theorem. Let's start by labeling it. So I'm going to label this side A, and this side is going to be B. And I remember that the Pythagorean theorem is a squared plus b squared equals c squared. So I need to put in my A into the right spot, and I need to put in my B into the right spot and go from here. So I'm going to have 5 squared plus 12 squared equals c squared. So 25 plus 144 equals c squared. So I have 169 equals c squared. But I'm trying to solve for c, not c squared. So what I have to do next is I have to take the square root of both sides, because whatever I do to one side, I have to do the other side where the equation remains balanced. So the square root of 169 is 13. And the square root of c squared, well, the square root and this to the second power or squared, they actually cancel each other out. So I'm left with just c. So I know that my hypotenuse has a length of 13. Let's try this in a real world problem, shall we? So I took a picture of one of my TVs that I had in my apartment, and I measured the side lengths with a ruler, or actually with a tape measure, and I can kind of show you how it's gonna work out here. I don't want that, I want this. And this is actually how they go about trying to determine sizes of TVs as well. So they find one side length, and they find the other side length, and then they actually measure the size of TVs on diagonals, okay? I can tell that this is a right triangle. I'm going to be solving for the size of my TV or for my C, the hypotenuse, and I have side lengths A and B of 15 and a half and 27 and a half. And I remember that the Pythagorean theorem is A squared. That looks a little bad. Let's retry that. A squared plus B squared equals C squared. So I need to put in the appropriate spots the appropriate numbers. So I'm going to move down here, 15.5 squared plus 27.5 squared equals C squared. Well, 15 and a half squared is 240.25 plus, and 27 and 5/10 squared is going to be 756.25 equals C squared. I add those two together, and the sum is 996.5 equals C squared. And now I have to take the square root of both sides in order to get C by itself. And the square root of 996 and 5/10 actually comes out to be roughly 31 and 5/10, which is actually, when I measured with my tape measure, that's roughly what I came out to be, 31 and a half. So they might round this up and call this a 32-inch TV. Okay? Let's try this another time when we're not solving for the hypotenuse, when we're solving for one of the legs here. In this case, I'm trying to solve for B, one of the legs. I don't know what it is, but I have my side length A because it's one of the legs, and I also see that I have the longest side over here, which means that 15 has to be my C, okay? So, going back to the Pythagorean theorem, which is A squared plus B squared equals C squared, I have my A of 9, and I have my C of 15. So now I just need to write it into the appropriate spot. So I have 9 squared plus B squared equals 15 squared. So 9 squared, or 9 times 9, is 81 plus B squared equals 15 times 15 is 225. Now I need to try to solve for B on its own. So I need to subtract by 81 on both sides. And I get B squared equals 144. Now I need to take the square root of both sides. The square root of B squared is just B, and the square root of 144 is 12. So I know that my missing side length, or side length B, is 12 units long. Okay? One more example. One other interesting part of the Pythagorean theorem is that it can actually tell you if a triangle is considered a right triangle, because sometimes it's a little bit hard to tell. Like in this example, it shifted a little bit. Maybe we're not necessarily thinking that it's a right triangle, but we can determine if it has a right angle in it or if it is a right triangle by using the Pythagorean theorem. Okay, so I have side lengths 10, 24, and 26. Well, if this were to be a right triangle, that means my hypotenuse has to be the longest side, so 26 has to be C, which we can make 10A and 24B. So again, remembering A squared plus B squared equals C squared. I need to put these appropriate numbers into the appropriate places. So I'm going to have 10 squared plus 24 squared equals 26 squared. Okay, well, 10 squared is 100, and 24 squared is 576. and 26 squared is 676. And when I add 100 and 576 together, I get 676, and 676 equals itself every day of the week. So does this triangle have a right angle? Yeah, it does. Yes, it is a right triangle. Okay? So now it's your turn. I want you to go ahead and write any questions or comments that you have in the comment section below. It could be, Mr. Gerber, I'm still not exactly